Welcome IG students. Today I'm going to be sharing with you a couple of videos based on the exam paper that you're doing for today, which will be Monday of week 10 for you. So this is page 17 of the exam paper. You're just doing page 17 and 18. Now if you haven't tried this question on your own yet, pause the video, go and have a go at it yourself. It's very easy to think you understand something when someone else shows it to you, but maybe having a try by yourself first is probably the best way to approach this. And then come back and see if you've got the right answers. And if not, you might see where you went wrong and it might help your understanding. So please try it yourself first. We have to write, first of all, part I, we're trying to write OA as a column vector. Well, let's just have a look. We've got 2 points here, A, 0,5, we've got B, minus 3,4, and we've got 0 or O, which is the origin, or 0, 0. So writing OA as a column vector, we've got to look at its x and y change. From here to here there is no x change, so we write it as 0. And our y change, of course, is we've gone up 5, so the column vector will simply be that O5. Hope you're happy with that. That's fairly easy. The next thing is we've got to write AB as a column vector. So we're going from A straight across here to B. Well, what do we have to do? We've got to go from 5 to 4. So we're dropping down 1, and then we're going across 3. So we can write this as our x changes minus 3, we've gone back this way 3, and we've dropped down 1, so that's minus 1. Okay, I hope that's making sense for you guys. Just going to rub a few things off here so that we can get on with the final part, which is the tricky part. Okay, now what we have to do now is we are told that A and B lie on a circle with the centre O. So this is our circle here, and these guys are on a circle. They're both on the edge of a circle, which means that they must be the same length, because a radius to the edge of a circle is always the same, right? Obviously, otherwise it's not a circle. So we know that this length is 5 units, and therefore this length must also be 5. Now, if you don't believe me, you can use a bit of trig. You've gone back 3 and up 4, and you can do trigonometry, a 3, 4, 5 triangle, so this must be 5. Okay, I hope that makes sense. We want to calculate the length of this arc that I've drawn here. What is the length? Well, to know arc length, you need the formula theta over 360 multiplied by pi d. What do we know here so far? Whoops. We know the diameter. The diameter must be double 5 because that's a radius. So the diameter is 10. Pi, we've got in our calculator, 360 obviously. We need to find theta. In other words, we need to find this angle here. How are we going to find that angle? Well, we do have a triangle here, don't we? We've got this triangle here. Okay, maybe I should do this in a different colour so you can... Right, this triangle here. We could find the length here, and then we'd have 3 lengths and an angle. And at this point you should be saying, 3 lengths and an angle. If I know 3 lengths, I can find out the angle using the cosine rule. So let's see if we can figure out what this blue length is here. To do that, we'll just look at the column vector that you used. You have gone down 1, so this is 1, and you've gone across 3, so this is 3. So now we can work out this length here, this blue length here. So AB, the magnitude of AB, or should we say the length of AB, is equal to the square root of 3 squared plus 1 squared using Pythagoras theorem. 3 squared is 9, 1 squared is 1, so square root 10. Okay, so that's the length there. Now we've got 3 lengths in our circle. 5, 5, square root 10, and now we can find theta using the cosine rule. This is where you're going to need to get your calculators out if you haven't managed to do this on your own. So the cosine rule is a squared equals b squared plus c squared minus 2bc cosine a. Now a in this case is going to be this angle here. So this is a, or theta, right? So that's that one. And therefore side A is this one here. So that's going to be side A because it's opposite angle A. I hope that makes sense. So we can now start chucking in some values here. Square root 10 squared equals b squared. Does it matter what is b or c? No. Plus c squared minus 2 times 5 times cosine A. Now, we can pull everything across. So, it'll be, well, this is 10. 10 minus 25 plus 25, so that's minus 50, equals negative, this is negative 50, negative 50, sorry, I'll just rub that out. Negative 50 cosine A. 2 times 5 is 10, 10 times 5 is 50. Okay, hopefully that's alright to you. So this is minus 40 is equal to negative 50 cosine A. So negative 40 divided by negative 50 is going to be 4/5. And therefore A is equal to the inverse cosine of 4/5. And if you do that, you should get, I think it's about 36.87 degrees. Make sure your calculator is set to degrees. Okay, so we now know what this angle is here. This angle is 36.87, or probably better to save your unrounded number in the calculator. Now the final step is to work out the arc length. We now have everything we need. So arc length equals 36.87, that's this angle here, divided by 360, because that's the fraction of the circle that we're dealing with, and then we're going to multiply it by pi times 10. And if you chuck this into your calculator, and you can pause and do it now if you didn't manage to get this, you should get, well, I'm getting 3.22. Hope this video helps you understand how to solve that question. It's a biggie, it's worth 6 points, so it's probably well worth understanding the processes there. As always, if you've got a query about this, send me an email and I will try to assist you as soon as possible. Good luck, guys.